Alright, so the plan for today is to add some new keywords for our tokenizer and some, identifiers, other instructions, things like that. And yesterday we managed to have integers and some operations, but as I said, this won't really be the case anymore after we add functions because, if we have functions, we might as well just have a main function with all of these inside of it. So right now it's just to figure out how this thing will work. So if we build our compiler and then run on one of the examples, let's see what the example contains actually. Example, right, it has some numbers, then an operation, another number, and another operation. So as you can see, it's like the reverse Polish notation for math, right? It's basically adding all of these numbers on the stack, then applies this operation, adds this thing on the stack, and applies this operation on the result of the first one and the second number. So it's, yeah, it does that. And the return code of the program is the last element from the stack. So here you can see that at the end we'll have something on the stack, and if we, let's say, change this thing to a plus and recompile the example, we actually generate the assembly, right? So that's pretty interesting. We get status code of 69, right? So because that's the result of that. So yeah, for today, as I was saying yesterday as well, I started to, play around with some language spec, how I see it looking. So let's actually start maybe with adding the data structures. So these are going to be our data types, and they use a data keyword, and then after the data keyword we have some random characters. Probably we can use letters, numbers, maybe underscores. I think that I really like the idea of having like even more characters in the name of identifiers, like dots. I don't know if, yeah, I was like, yeah, let's use, but yeah, I mean, dot is quite nice to use for functions. So yeah, so we'll have some identifier, and then we'll have the list of fields, right? And here you can see that we use integers for this example as the fields. And of course, the data structure by itself won't be that useful because right now we have this plus and the minus, right? So we have only two instructions, and these two instructions are supposed to work on integers. So we cannot really use the data structure, like we don't have any helpers, right, to access the fields. So the point would be then, but I'm not sure if we'll have time to, because to have the data structure, we also need to implement the AST, right? You see that this thing kind of needs some kind of parsing, because we'll have, the data, then a random string, then parentheses, but we kind of want to build this into an object, right, in our compiler, and say, okay, an IVEC2 has two fields, like we want to know some information about it. Having just tokens, like we did for math operations, wouldn't be really enough to have that information, right, about what an IVEC2 is. So yeah, we kind of need an ST for this one, so we'll try to also do that. And then obviously we need functions to be able to actually use these data structures. And you can think of the functions the same way we look at plus. For example, plus is a function in this stack length because it takes two arguments, two integers, and it produces one integer. So it's kind of a function. And for data structures, we'll have the compiler generate for us some functions. For example, the constructor is gonna basically take in the list of arguments from here. This is gonna be its parameters. So for example, two integers, right? And it puts on the stack an ivec2, right? So it's not like on the stack we'll have two integers. On the stack we'll have straight up an ivec2, like you can see it as a thing on the stack. So the first thing on the stack is going to be an ivec2, and then comes whatever else was on the stack, right? And then some other functions that I think are going to be important to be generated right away by the compiler are some functions that access the fields. So for example, it can generate this ivec2.x function, and this function can be used to get an ivec2 and return an int, right? So this is how the function would look like. The implementation, is not really important because it cannot be done with like it cannot be written in our language. It has to be done by the compiler, right? Well, you can think of it as something like, let's say that in our language it's possible to have some operator add, and add would do something like it looks into memory at the address of ivec2 and offset 0, right? So something like that. And maybe for y would be offset 1, right? But we don't have that operator, so but we could add it and then implement these by hand. But I still think that the compiler should do these functions. Would be so much nicer, right? And then you can actually just use ivec2.x, ivec2.y. Maybe you want to implement like adding the x and the y, right? So what you would have to do then, let's just write that, is let's imagine we also have dup, and dup just duplicates the first item from the stack, right? So you would duplicate the ivec2. Oh, I think a nice way of thinking about it is to have like this is the stack. It's we imagine the stack here, and then if we call dup on it, you get two items on the stack, right? So this is the result. Then we call ivec2.x. So the first item from the stack converts into an int, right? Then let's say we swap. So swap would actually rotate the first two elements. I overshot there. It rotates them, and then we call ivec2.y. So this thing turns into the y element. And then if we call plus, it converts that into a single integer. So, something like this we can use afterwards to implement basically this, but with an ivec2. So I think adding functions and data structures would make the language a bit more interesting. It's still not gonna be, Turing complete because we don't have ifs, but that's gonna be the next step afterwards, right? So you can do even more complicated things though, like implementing dot product between two ivecs, right? So the data structure and the functions are in a way not really let's say supposed. I mean, they are just a way to add some syntactic sugar to the language, right? To make things a bit more readable. So instead of having all of this stuff as just a list of instructions, you can remember that in brainfuck it was insanely hard. Let's just go to bf compile. I think I have some examples in brainfuck. So like the digit add, right? Like it doesn't make any sense what's here, or even the full adder when we implemented the adding two numbers. It's like the name of the language really, you know, it's really good for how this thing looks like. What the fuck is going on? But if you think about it, that's how this language with dup plus multiplication minus would also look like. But if we add data structures and functions, we can take a group of smaller instructions and put them into a function, right? And that function gives us some meaning of what this thing does, because here I used comments in brainfuck. Like, sure, this is a div mod algorithm, someone was able to create it and I copied it, but it's not like a function that has a name and it's part of the like syntax, right? So that's what I'm trying to achieve with this data structures and functions. Try to add this like list of mumbo jumbo instructions and give them a name, kind of. So yeah, let's actually try to add some of these into the Lexer, and then I guess adding both data structures and functions at the same time might be easier in one way. So we can do that. And then actually implementing the AST for both of them. I think, yeah, we can do both. So yeah, let's go to the main file. Right. So yeah, we still have a bunch of, you know, assembly stuff, so don't mind that. But what we are gonna add here is in our stack token kind, we'll start by adding more tokens. So for example, stack token data, this is gonna be the data keyword, right? So if we go to the readme, you can see data. Then, as I said, we'll have the data structure name. But you know, data structure name is not necessarily a token. Data structure name is more part of the AST, because you see the tokenizer doesn't really have a context of what has been read. It only works by looking at the current token and deciding, well, it looks like a random string, like, right? But data, I mean, you know, data looks like data, so it guesses that it's a keyword. But this thing, it's just a string, right? Just not necessarily a string, but an identifier. So yeah, so I would say we can refer to that as stack token ident, right? And in this language, this is an identifier, this is an identifier, the function name is an identifier, right? So that's how we are gonna do that. But in the parser, this is gonna be the data structure name, right? So that's why we need a parser, because the parser actually knows how to differentiate between this identifier, this one, and the function name, right? So that's why we need the parser. Okay, so next up is stack token left parenthesis, and let's also do the right parenthesis. Okay, then here we have you know, would be cool to be able to differentiate between identifiers and types, but I don't really want to do stuff like this, right? In cool language, that was the idea, right? We had classes, which are types, and we had identifiers, which are just identifiers. And to differentiate between them, we had classes with uppercase and identifiers start with lowercase. But I think I don't want to do that here, because the parser is supposed to differentiate. So even this int is gonna be an identifier. even though it's a type, but that's for the parser to decide. Right, and then we have another identifier, which is the field name. Then we have a comma, right, in here. And that's kind of all the tokens that we need for data structures, for our data types. So let's take a look at function. Function needs stack token func, which is the keyword. Right, keywords are easy to identify. Then identifier, we have an arrow. Arrow again is something that we can add because it's, and here don't make the mistake like to say, okay, this is a minus and this is a, I mean, maybe the font is not the best for this explanation, but you can see that this is a minus and this is a greater than symbol. Like the token itself is both of them combined, right? It's not minus and greater than, like you have to not make that mistake. The token itself is actually the entire arrow. Then we have an identifier, we have the in symbol, then we'll have some random stuff inside, and then we have the end symbol, so end token. Right, now don't really care about this, honestly. So, but yeah, I mean, sure, fair enough, this one is interesting to have. Well, I want to put all of these first. So token data can be like return, let's say data, return ident. This thing is a parenthesis. Same thing. Oh my god, why I forget the comma. Func. It's an arrow. Right, just to not have any compile time errors or warnings. Okay, so that would be what we need, right, to be able to parse the new stuff. So let's actually go to the example and let's add a data structure. So example, let's add this thing. It has syntax highlight, that's cool. I'm not sure what SL is, but I appreciate that. Wait, if I do, doesn't help. Yeah, I don't know what SL is for, but we'll see if we can override it. Yeah, so we'll try to parse these two things. So as I said, at the end probably we'll have a main in, and here we can do like 69, and that's the exit code, right? Something like this. But wait, can anyone think about dot product that returns 69? That that would be the actual, like, if we compile that, we are good. Anyway, let's go back here. So that's gonna be the plan, right? To be able to at least parse that that entire thing. So as I said, I'm not sure I want to keep this stuff with the toAssembly because it's not really gonna work. Like this was, I mean, it's in the Git history, so I think that's the proper way to use Git. Like just go back to when that thing existed. So yeah, we have this token kind now. We know how to display it in case we want to display it. And now we have the stack token. Right, we have the stack token. And here we do some stuff. So this one is stack token to string. So this thing should display the stack token. I guess it can be like a public function maybe, or let's keep it static or whatever. So yeah, this thing just converts a stack token, this thing, into a string. Yeah, that could be useful just to validate that we parse the thing correctly. Alright, so we can go here. After we parse a token, we can do, oops. Let's do this log info stack token to string, and we can pass the token. Okay, I don't care about this either. Okay, let's go back. So yeah, we'll print the tokens. Then we have the lexer, right? The pick, read, skip white space, init, and here we have the tokenized number in case we have numbers, right? Then we have white space, skip. Right. Oh, so what I was thinking actually is, you know how I said that these are all functions? Right, like what if we actually make all of them functions? Right, so we don't even have the plus symbol anymore or the multiplication symbol. Like these are just functions. Like star is a function. Somehow it can make sense, I don't know. But maybe like imagine this actually, right? Int dot star, int dot plus, or whatever, because that would be nice. But I think that since integer is gonna be something like the default main thing, like integer is the basic stuff, maybe we don't want to have, like, we want to have a type that's just like this. And then, for example, if we have a float, we have addition for floats, right? Or multiplication for floats. Yeah. And that way, oh, if you think about it, that means that float multiplication, so float multiplication will work only on two floats. So then we need a function that converts int to float. So right, but yeah, that's far from where we are right now. But I think that I want to have everything else be a function, or everything else be an identifier. And this is a number, but all of these are identifiers. That, imagine, like, how cool would that be? So that means that we don't have a plus here. But I'm wondering how are we gonna implement these things. Yeah, I wonder how are we gonna implement these things, because yeah, I mean, it's gonna be, I guess, the same way we are gonna do with dupe. So for example, dupe, we already know what it does, right? It duplicates the first item from the stack. But plus, it adds two elements from the stack, so it can be part of the compiler itself, right? So we'll have a list of functions, and we'll have a list of functions that are already implemented, and we have the assembly for them, and the list of functions that you have to implement because you added them. So I think that's gonna be the plan, actually. So ident, it refers more to like function or name or something. Maybe a name would be a better convention for this. So this is a name, right? We have data and names. I think that's, I mean, this is a, so we have only names in our program, right? Oh, for this stuff I use like uppercase, so I can just, okay. I think that's good approach. So we don't even need symbol plus and minus, so that's another thing. Okay. I mean, in a way, it makes sense for that, but like for numbers, right? But yeah, as I said, we'll have like this part. Right. It's gonna be interesting. So we'd have to define what characters we can have in a name. And I guess a name can be anything except parentheses, arrow, comma right now. So in our tokenizer, if we place those checks with a higher priority, so first, we'll not have to worry about it. So let's say we take this thing, and if we check for, I mean, it's, I don't know if I like this symbol minus. I mean, it repeats quite a lot, so using a define clearly makes sense. Define symbol L paren. I guess it makes sense, right? But just in case it repeats, and let's have greater than also symbol because it's needed. But yeah, so here, if the character is a symbol L paren, then we read something token L parentheses. It doesn't really have a value, right? So that's that. Let's also do R parentheses. Right, so we got these two symbols out of the way, these two tokens. Let's also do comma and arrow. All right, so I'm gonna copy this symbol, comma, we need to add it. Comma, and if it's a comma, then we have a token, comma. again, not doesn't have a value. But now it's gonna be kind of interesting. So I said we have negative numbers. Right, so a number can have a minus. That's useful to know. Okay, but plus is not longer here with us anymore, so it can go. So if we encounter a minus, and I would say that the next character is greater than, and we do peek and say this thing is equal to symbol GT, then we have token arrow. Right, so if we have a minus and the GT is like a greater than symbol, that entire thing is an arrow. But what we shouldn't forget is that we have to do read twice, because here we read minus and here we read greater than, so we have to skip both characters, right? So that's the point, right? But if we have a minus and then we had a digit, then that thing was a number, right? So yeah, that's one way to do it, I would say. I mean, this thing is a bit overkill, but yeah, it is what it is. Okay, like sure, I could just copy paste this thing into there because it kind of makes sense, but you know what, like I'm not even sure what value is used for here, if I'm being honest. Yeah, I think it's gonna be nicer if I just do it like this, I'll be honest. Even though like having a separate function might be nicer, I feel like this is gonna be more obvious. So yeah, here we have the end of file, here we have left parenthesis, right parenthesis, comma, arrow, then numbers. Right, so if you read a minus, then you start with a minus, and then return differ 0. So we remove all of that failure cases. Okay, so we also were able to read a number. All right, we did all of this easy stuff, but now we are left with data, name, function, in, end. We have some keywords, right? So that's kind of on the else case, almost. And I don't think we really have illegal characters. Like mainly any character is gonna be like any character that we encounter is gonna kind of be a name, right? And besides the name we have data, in, and func. So that's like a few things. But maybe there is so we have this is digit, right? But maybe we have a is something else. Let's see what other options we have other than is digit. So is alphanumeric, is print. I think is print is what we actually need, like printable characters. So let's see if I take this thing, I can come here and say something like if is so what was it, is print. Like, sure, maybe not really all the characters, but maybe most of the characters that we have on the keyboard can be function names, right? So let's create a slice. Here is gonna be more interesting. We have a slice and then a while loop, right? So while the character is printable, we move to the next character in the buffer and we increase the slice length, right? And maybe this is gonna be a problem. Like, let me just let's create a test.c, include one sec. Oh, I have ds.h, perfect. ds.h. I was like, oh yeah, yes, is print. I don't think we need it. Is space printable. Let's see. Today we'll find out. I have to next develop. Oh, what? I guess that means it is. The fuck? Wait, I don't know. Is digit. Let's see if we recompile it. All right, so that sucks. Kind of. I mean, no, it was expected, but so we cannot really use is printable. But what we can use is our own function. So let's create here like is name or something, char c, and maybe we can do something like is print c and not is space c. Yeah, we don't need c type. I think maybe that's how we want to do it. So it's gonna be all the printable characters but not spaces. Pretty sure it exists. Like, what is graph? Or maybe we can say alphanumeric or punct, like punctuation characters. But I don't know what graph is. Yeah, anyways, let's keep it like this. Let's say let's actually say is unknown and actually or is punct. But see, like star, is it a punctuation character? I don't know. We'll figure out, right? Like, what do we need to say for is name? Anyway, let's imagine that it's gonna work. So while we have a name, that's that, right? But now, see here, we did something like this. Right. Imagine we do something like this. Name. That's kind of right, right? But the problem is, what if this name was actually func? We want to say, okay, then this thing is supposed to be func instead of a name, right? So we need a kind of if statement. If ds string slice equals, I mean, I have starts with. What other functions do I have? Starts with strings step empty free. I mean, it's funny, I have starts with, but I don't have equals. As, or like as other or something. Okay, let's go here. Let's add this bad boy. So what it should do is basically this, but on top of that, and, right, it has to be an and with, well, this is ss, or maybe it's the first thing, just to not, you know, who knows what the fuck happens if I don't do it like this. Like maybe the length is, you know, it causes some kind of overflows and then segmentation faults. So maybe if I do this check first, make sure the length are the same, only then you can actually do this. Yeah, like even here, maybe the correct check is to check that the prefix length is smaller than ss, but that's something I don't care about. Okay, so string slice equals, right? All right, so here I should pass the slice, and here we need to build another slice. It's kind of annoying. Like, would be nicer if I had check if string slice is equal no, because whatever, I don't care. Equals. Okay. So what I would do then here is have something like slice func, like maybe a define slice func, and then this thing is ds string slice. How do I do it? Like this, and then str is equal to func len kebab len is equal to 4 and allocator should be null, but I'm pretty sure that that allocator, where is it? Yeah, it's a pointer. Okay, anyways, so would be 0 by default, but yeah, I don't think there is a length for constant chars. Like, can you use something like dash func or something to get the length like you do in assembly? I don't think so. So yeah, let's hard code it. So we have the slice for a function. Let's say we have a slice for data. Right, we have a slice for in, which is 2, and we have a slice for end. And basically these slices are like string slices from Rust, right? They have a pointer to a string and the length, like not like in C, like the char pointer. Okay, so that's the idea. Perfect. Let's go now to our error. So here we try to compare. Oh, we need the address, but I think that's fine. So we try to compare these two, which returns a boolean. If this thing is true, then we want token to be func, right? But the rest is the same. Then we have an else. If it is in, we want this thing to be in. Oh, and here we don't even care about the slice because we know what the slice is. Like, it's not even okay. Then if we have end, we put the end token, and if we have data, we put the data token, right? And on the else case, it's actually everything else. So here we have a name, but here we actually need the slice. All right, so that's how I would do this part. And yeah, I'm not sure if we are gonna have illegal tokens, but that's how I would actually parse it, or I guess tokenize it. We don't have parsing yet. Oh yeah, we do some bullshittery there, but that's fine. And what I really like about string slices is that they don't allocate memory, so it's a really good way of using them. And it's less error prone because string slice is something that I implemented a while back, so I already know that it works most of the time, and if it fails for some reason we can just go fix it, and it's fixed for all the projects that use string slice, so that's nice. Anyway, let's see if this thing actually compiles. So let's make, and if we run main example.sl, oh, we actually get something. So we get like data, the name it's an IVEC2, some parentheses, and then the arguments. Something happened here. Oh shit. I mean, it makes sense because I said that any character can be a name, so yeah, here it makes sense, right? But And if you don't see it, it actually found y parentheses as identifier. So if we go to example, you can see that this looks like an identifier for our tokenizer, because that's the rules that we wrote. It's like that's what we set the program to do, so it actually did that, right? So let's go here then and say, so is punct actually finds these as punctuation characters. Okay, let's put a parenthesis around this and say and not, and c is not equal to this, or maybe and c is not equal to this. So let's rebuild this, and now if we go again, you can see that it actually found it as a parenthesis, because we said that, okay, these are never going to be part of names. But we have data, we have the name of the data structure, then these are still names, right? They are just some names. It's up to the parser to decide that that's a type. Oh, and here as well, maybe comma shouldn't be part of the, and c is not a comma. Maybe comma again shouldn't be part of names. Right, so yeah, now it found it as a comma and everything seems fine, but I'd say dot should be part of names, like ivec2 dot. Then we have some types, the arrow, name, in, and then we have a list of names. Looks good to me, to be honest. Like probably this is gonna be the bulk of like the body of the program, a list of names. List of names or numbers, or in the future maybe strings, but for now we have names. Okay, then end func main in number and end of file. It really looks it looks pretty good. Let's see, I'm curious. So if we go to example, is let's put all the characters. I'm curious which one is gonna be illegal. I think these are all the I mean, yeah, whatever. Oh, and probably damn, it's quite a lot of characters actually if I think about it, but well, we kind of know that comma is gonna be a comma, but yeah, let's see if so. Oh shit, this is an entire name. That's funny. What did I expect though? So these are all okay. I don't know if I like that. Like imagine you have a name like this. I'd say that probably double quotes shouldn't be, but for now we can leave it because it's gonna be part of a string, and maybe even greater than and less than shouldn't be part. Oh, but no, because less than and greater than are gonna be functions. Yeah, they're actually gonna be functions, so it's fine. But yeah, only the double quote, I think. Obviously some of them don't make sense, like why would you have a brace in your name, but Yeah, anyway, I guess, no, this is fine for now. Maybe we'll figure out that we need to add more stuff here. Okay, but actually, this could be a define though. Is name, and we don't do like return or that. We just put a big parenthesis around it, and we say unknown. We need extra parentheses around C when you do this kind of stuff. And here can be symbol L parenthesis, and you need extra parentheses because some like equal operator has some precedence, and if you enter here an expression instead of one character, it might mess up with the precedence, right? So that's why we need extra symbol R parent. Yeah. So imagine that instead of like character V, you actually have 1 plus 2 plus 3, and right, you need a parenthesis, or I don't know, symbol comma. Maybe you don't need a parenthesis, but at some point, if you keep writing this kind of defines, you'll find out that you need. Okay, so does it still work? It does in fact still work. Perfect. So yeah, that's pretty nice. So one thing I didn't like about the JSON parser was that I made the lexer part of the parser. So it kind of makes sense, right, to have, because it's like an this thing is like an iterator. You call next and it gives you more and more tokens. But if you need to peek into the next tokens, it kind of sucks because you call next multiple times on the same lexer, so it feels a bit inefficient. But even building a list like an array with all the tokens beforehand, that also feels a bit messy, because I really like the lazy approach of explicitly asking for the next token, but I don't really like that this thing actually consumes the buffer. So yeah, I'm not sure what other approach I could take here. So when you call to next, right, you get back a token, but at the same time you also modify the lexer, right? You move the lexer forward. But what if you, let's say, want to check what token you have on the head, like on the read head, for example, because maybe, I don't know, maybe you want to check that you are in an if statement, right? So you want to check that the first item is an if, or something stupid like that. Feels a bit weird. But what we can do maybe is, because right now I want to go to the parser, right? I want to implement the parser. So right now we can build the parser data structure and try to build that AST of our language. Currently the AST is gonna be extremely simple because we don't have that much, but let's still try to do it. So let's have a type def struct. How do I call it? Stack parser. I think that's how I called it. Yeah, stack lexer, right? So I think that to avoid my problem with having to pick is obviously I'm still gonna, so if you don't know what I'm talking about, I did this JSON C, I think it's called, like 3 weeks ago, and oh shit, yeah, actually it's part of yeah, actually I totally forgot it's part of ds.h now. So yeah, like if we need in the future to parse JSON, we just have a JSON parser in ds.h. That's really useful. So yeah, let me see if I can find, actually I'll just go into ds.h here. So JSON parser. So see, it has a lexer as a field, right? And see how the lexer looks like. It has a buffer, and then it has all of these helper fields. What if we do the same for the parser? What if we add these helpers just so we know like what's the current token or the previous token or something like that, and then we can read how much we want and then use this as the token. So I think that's what I want to do. Maybe that's gonna help. So I don't know why lexer stack lexer. So we'll have the lexer just as here, but what if we have also something like stack token, let's call it toc. So toc might be something like the current token, right? Something like that. And yeah, okay, makes sense, right? Makes sense. And I'd say let's try to have these functions, but for the parser. Stack parser pick and stack parser read. I don't know. Yeah, let's try to have something like this. So instead of calling lexer get next token directly, we'll try to use these functions. Right, so stack parser pick and stack parser read. This should get the parser, so it gets like self. So parser. It's a private method, sort of speak. So I don't think we have this check for picking. I think that picking actually just returns, oh, and here it's not a token, it should be a stack. Oh, it's not a character, it's a token. I think what we have to do is just return the token if we pick. Alright, what the fuck, this was so weird. So maybe we need two tokens actually. Maybe we need two tokens. We need current token and next token or something. Token and token ahead. Token and next token. Right, we need two tokens. The current one and the token that's ahead. So if we pick, we need a head token. Right? And here let's say that we call read, so the current token becomes the next token, so we move the look ahead and stuff. Here we need to get next, so we also need to do something like parser next token is equal to stack lexer next. Oh, this one is yeah, is like this. So this stuff should be something like parser lexer and parser next stock. Obviously we need the references to be able to change them. This thing returns an integer, right? So it can fail, but it can fail when it returns 0 0 0 0 0. Cannot really fail if I think about it, so maybe it should be a void. I don't think it's possible to fail on this. That cannot fail. These equals cannot really fail. So I don't think it's possible to fail on this. So then the question is, maybe we can, oh, what the fuck did I do here? Maybe we can even have this return the stack token. But yeah, like that can make sense. That can make sense to make it return the token instead of that. Should I change it like that? I guess, why not? So here instead of this stuff we should do return. Right. And I think it's going to be safe because this thing doesn't allocate anything, so we don't need to free stuff, hopefully. That was my only idea in the beginning, like maybe we need to free things at the end, but I don't think it's going to be the case. So stack lexer next. Apparently this one is going to be like this, so we read the next token, and here we need to return parser token. Oh, and here it's yeah, stack token. Right, so that's how I see it. Peak looks at the next token, read does this stuff, and yeah. So next big function, if we look at lexer, whatever, that's not important, is initializing, right, the parser. So initializing the parser, stack parser init. Obviously we need a few things like stack parser, we need a lexer, and that's kind of what we need. And here we're gonna say parser lexer is the lexer that we got. Oh, and we don't need the reference. And then, well, we could say talk is equal to 0 and next talk is equal to 0. I guess that's how fuck? Can't I just say stack token? Yeah, I guess so. Like 0, right? And then here we do stack parser read parser. So we don't care about the first read, we just want to initialize next token with its next token. So now we can have a look ahead, and I feel like it's much better than how I did it for the JSON. But you know, like first time wasn't that great, second time better, I guess. Maybe, you know, first time was when I did cool compiler, and then I actually read all the tokens, put them in a list, and honestly I think that's the worst. Then a little bit better for JSON, and now I think this is the actual way to do it. Just replicate what you see that works, and you know, what I think that works is this Lexer implementation with pick and read. So yeah, I mean, hopefully I'm not, you know, too early and it's gonna fail terribly, but I feel like it should work. Okay, so here let's say token is equal to, right, I think this thing obviously should still work, hopefully. Yeah, so stack Lexer next. I think, yeah, it's a good way of doing it. Right, it just returns the token. Okay, I don't think anything can fail, so we don't have to worry about error. I mean, let's be real, if I run Valgrind, obviously we don't free memory, but that's beyond the point. I think what we need to free is, first of all, wait, we free the argument parser. Yeah, actually I'm curious, what do we, oh, stack token to string, we don't free this stuff. Right, yeah, we don't free it. Okay, so if I do something like char pointer value, and then we print the value, and then ds free null value. Obviously that's one big thing, but we still have allocated stuff. That's interesting. Well, one of them surely is the buffer, but ds free, well, let's do if buffer it's not null. Like, obviously we still lose some stuff, but it was 39 before, right? I'm not sure what else we allocate and don't deallocate, so let me just go from the beginning. This clearly not allocated. Stack token to string. Here we create this string builder. Here we own it into this buffer, but at the end we free the buffer. Right, so this string slice is actually freed. Huh. You know what, since we compile with debug, let check equals full and dash s. Oh, then we do something with the dynamic array. What? Stack token to string. Yeah, I mean, I freed that. So, oh, wait, what? Stack token kind. to string. I mean, that's not allocated, so what? String builder open. Oh, I know what happens. It's string builder. We forgot to say this string. So even though here we call to build, we still have to string builder free sb. We still have to free it, right? So that was the issue. So now if we lick check, everything is freed. So we are also responsible C developers, not only that, yeah. Anyways, so should we go maybe in a bottom-up way? So let's try to parse this thing. Maybe, that's gonna be enough for today or something, I don't know. So the data structure, just to get the feeling of how to do it. So I'm gonna do probably int stack parser parse, let me do it static, parse data. Right, so the stack parser comes here, and what we also need is the st definition. So the st definition is gonna be something interesting. So let's say type def struct, and here let's call it stack st data. Stack st data. So stack st data, I think it's gonna refer to this thing. I think that's what it's gonna refer to. Stack st data. So what fields does the data have? Well, should have the name. I don't know if I want to use string slices for this too. ds string slice, how about that? Right? String slice. So that's gonna be ivec2, for example. And then we might need a list. So ds dynamic array fields. And for that we need the implementation for the a. Wait, it's strange, I'm using string builder, but I haven't imported it. I guess it's used in something like IO. So dynamic array fields. Pretty sure we're gonna need a dynamic array of fields. And this dynamic array is gonna have what items? I should have some kind of field type def struct ds string slice type ds string slice name, and this is gonna be stack st field, or maybe data field. I feel like being a bit more explicit might be better. So the data field. could be an idea of a name, right? So it has a type and the name of the field. I think that's how we are supposed to do it. Maybe this thing should be here too. Okay, so let's do actually another function. Oops, what did I do? Let's have another function for stack parser parse data field. So how are we gonna parse a data field? Right, and it's gonna return stack ast data field. Right, this is a return 0 to do. Right, it's a to do. Implement this bad boy. Right, and let's just imagine that we have this implemented, so we can do the more fun one, because that's basic. Stack ast data. So it's a data. Let me just have int result is equal to 0 the result. So this guy is supposed to find some stuff when we look at the parser. So first of all, it's supposed to have a data token. So if I say if parser token is not equal to, or I guess token dot kind, but quick question. Now it's interesting. Should I do read or check talk? Because initially a talk won't contain anything. So I might have to do read first. Right, like something like stack token is equal to stack parser read parser. Right, and now we check token kind should be equal to data. So if it's not equal to token, stack token data, if it's not equal to stack token data, then we have an error. Also want to do nice error handling, but we'll skip it for now. Let's just do ds panic to do error for or maybe parser expected data found %s, and here we do stack token to stack token kind to string token.kind. Right, and we don't even need return one, but we can just leave it. Okay, so like, yeah, I want to have better error handling, so I'm just gonna do it like this to force myself. But yeah, so here we read a data token, so we know that we are inside of parse data. So now what do we expect is a name, so we do another read. Maybe let's just have it like this. right? So let's do another read, and we check that we have a name. Expected a name, but found something else, right? But now, since we have the name, we can just put it into our data. So data arrow name is actually gonna be equal to token dot value, because we have something, right? After the name, what's next? It's a parenthesis. So I think we need a parenthesis. It's like mandatory to have a parenthesis and at least one type inside, or maybe the void type. But what the fuck is the void type? Okay, let's say void type is a thing, so something like this, right? Void type can be a thing. So we read from the parser and we expect an L parenthesis. So we expected that but found something else. After this one, we need a do while. What do we need? A while loop or a do while loop? This is gonna be interesting. I think a while loop is gonna work. So if you think about it, a while loop means 0 or more, and a do while loop is 1 or more, right? So I think that I want to do another read here, and I'll say while token kind is not equal to stack token rparen, we keep reading, right? So if we find an r parenthesis, we stop. And since this is a while loop and not a do while, we can have the void type, which, I mean, it's kind of useless, but yeah. All right, so what's the next step? Well, the next step is to read a data field. Okay, so I'm gonna define here a stack st data field, maybe even initialize it with 0. How the fuck? Okay, sorry, we initialize this with 0 just in case, right? So we do that. Oh, and another thing that we need to do for our data is maybe to initialize it at the beginning. So let's do something like data name is equal to 0 first, like ts string slice. So initialize it with 0, and data dot, well, it's ds string ds dynamic array init data fields, probably a pointer, and size of stack st data field, right? That's the fields. Okay, so we have to initialize our thingy. Maybe we can put it here, right? So we just initialize our data structure just in case, you know, it's not initialized beforehand. And even if it was, it's better to make sure that we clean it up, because who knows what's inside of it, right? So yeah, let's just initialize it first, and then sure, we override the name. If this thing fails early, at least we know it's initialized, right? When I find some, willingness to change this to logs and stuff like that. So yeah, let's see. So this thing we initialize to 0 just to be initialized. Then we have to call to this function, to this stuff. So stack parser read, this thing needs the parser and a field. Okay, this stuff can fail, so yeah, I still don't know how to do proper. You know what, I'm not gonna fail it in case it fails. I still don't know how to do proper recovery from error, but maybe we'll figure that out together. So yeah, okay, anyways, here we imagine that we read a field, yes, dynamic array append, and now we add it to our data structure. I think I need field. Okay, I need to pass the address. Yeah, this thing can fail again. It's like a big to do here to do error checking. Like this thing can fail, and that sucks. It means that you ran out of memory, which is kind of impossible, but shit sometimes does happen. Anyway, next thing that we need to check is if we have a comma or if we have like the stop, which is like a parenthesis. Yeah, so let's think about it, because I still don't really like this approach. Like sure, here we need to read, and we need to find this stuff. Then we read once, but I think we actually have to peek. Damn it. See, like this part is a bit annoying because we found this, but I think we need to peek actually. I think we need to peek. And then if we don't have our parentheses, then it means we have the field. So we parse the field and we are on the next token, which should be a comma. I think this should be a peek. So we peek, and if we don't find closing parentheses, then we parse a field. Then we need to parse, but like a comma is not mandatory. We can have a comma or have a right parenthesis. So that's the thing that I don't really get. Like, how can we write this in a really short way, right? Anyway, let's do this one. Let's copy it. So here we read a token and we expect a comma, but we found something else. So this should be a comma. But the point is, okay, we have a comma, then it means we need to have another field. But if we don't have a comma, then we need to have a parenthesis. So that's my thing. Okay, what can we do then? can we do the reverse here? Like, let's say instead of this while loop, I do something like if token kind is equal to stack token L parentheses. This means that we can actually stop. Oh, instead, wait, let me just, this will not work, but it's still better than return. So I'd say if we find left parenthesis while we pick, we have to read it. We have to read it and we stop. Otherwise, we need a while loop. Right, we need a while loop. How is this while loop going to work? I don't even think it needs a condition here. Oh, so it means that it is a do while loop. It is a do while loop actually. So you can see here that if we find the left parenthesis, then we can just stop because it means that it's a void object. But if we have, in fact, if we are on the else case, and in fact we don't have a left parenthesis, we have a field, we parse that field, we append it to the dynamic array, we read another token, and here it's gonna be interesting. Yeah, I still don't like it, but I think this is better. I think it's gonna be a while one, like while true. Do I have a DS true? So while true, we read a field, right? We read a field, then we read the next token. If token.kind is equal to stack right parenthesis, then we can just break. Right, so we read a field, we read another token, it's a parenthesis, we break. Damn, it's still ugly as fuck, but. And then if we go over it and we find something that's not a comma, expected comma, or closing parenthesis. Still kind of hate it, but I really don't see how else I can write this. Right, like we need to look at the next token. Yeah, it's really ugly, but I think that's how you have to do it. And I don't really see another way. So we pick, if it's a closing parenthesis, then we skip it and return with success. Otherwise, if it is not a closing parenthesis, we read a field, we check if we have a parenthesis or a comma, and then we go again based on this check. So if we have this, we stop. If we have this, we go again. If we don't have either of them, it's an error. Okay, I mean whatever. So we just have to implement this now, which should be a bit more obvious if you'd ask me. So let's do int result is equal to 0, result differ, and we need token. So why is this one a bit more obvious? Because we just need to read two types. Let me also initialize field just in case it's not initialized. So it's going to be similar. Field name and oops, and I think it's field type. Yeah, so we initialize it just in case. So field type, and then another one for field name. Right, this thing cannot really fail. Yeah, whatever. So that's how I would implement this parsing. So let's try to run parse field first. Let's try to do parse field here. So I'm gonna do, after we initialize, let me just do stack parser is equal to 0. I'm not even gonna do tokenizer anymore. Just do that, and then stack parser init parser and lexer, right? Like that. And now we should do something like this. We don't even need that. But do we? All right, so here we pass parser, and here we need to pass a field. So field, it's also equals to 0. So if I do ds log info %s %s, and then say something like field dot, I need to do it. I mean, I can just do str, but that's not gonna work. Name type, I don't want to do it like this. Char pointer name and char pointer type, let's say, and then we can do string ds string slice to owned, and here we have field dot type. I think I need an address and address to type, and the same for name. So I think this should, unused function stack token to string. Stack token to string. No, like, it's weird because if it's static, you'd think that it's not used. But I mean, isn't this one used though? Oh, it's a stack token to string which is not used. It was used here. So annoying. I mean, let me just have this as well, just to... So stack token. So we should also see the remaining of the tokens. So it probably complains that we don't use this one, so let me just comment it out for now. Maybe the unused function is a bit too much for... Oh yeah, obviously. But as I said, I think I want to go to the makefile. And let me just go again and take this one. We add it here and say no unused function. So now it should work. Okay. Let's see, main example SL. So in example SL, if we do int x, that's a field. So if we run it, we'll see the result of that, right? It works. So that's nice. What if we go to main and we say something like parse data? So instead of that, we have data. I think data name is a thing, but we don't have type. So let's see the name of our data. Name is an IVEC2, right? But see it, yeah, I thought it's gonna be, but here because we passed this by value, it makes a copy, right? So it's not gonna destroy our old lexer. It's just the current one. Anyway, it looks fine. Let's just do something like for... Oh, you know what? That was useful. This part. Let's have a for int I is equal to 0, I is less than data fields count, I plus plus, and let's do something like this. And here I'm gonna do stack ast data field is equal to 0, ds dynamic array should be get, but why isn't it here though? But who knows. Data fields should be a pointer. I think we need to pass I and the address to field. So this should give us the list of fields. What? Okay, but I'm sorry. Whatever you say. So now if we run this, we should see IVEC2 has two fields, x and y, of type int. So that's kind of cool if you ask me. I guess what I have to do is a dump function to be able to dump the AST. Right, better error handling, because let's say for now, let's say it's gonna be something like you have an extra comma here. We run it. Expected a name, found parentheses. Like, it's pretty decent. Problem is it crashes the entire program. Right, so if I have another error, I want to report both of them. So that's the idea. Okay, and let's see if we miss like that. Expected a name, found that. I guess, yeah, it makes sense. So yeah, I want to do better error handling. Obviously, that's a big part of the lexer or the parser. Next up, we might want to do parsing for functions. So we add another AST here for functions. And then we might be able to implement some functions in assembly. Right. And for the assembly, that's going to be interesting. Not sure if I want, because the current approach, right, with, if we look again at the assembly, is to allocate some memory using sbreak. Not sure if I want to use malloc. So if you know from cool, we actually ported some libc functions into our language, and we link with -lc, and we can use malloc. But I think a better idea that I have is to maybe try and implement custom allocator in assembly somehow. And in ds.h we actually have a allocator. Where is it? We have an allocator. So what are the chances that we can compile it to assembly and just put it in our code? Like a bit of cheating, but we just need the alloc function, right? So this, and somehow we kind of need this part. I mean, it's pretty big. It's kind of big. Or like the other option is to compile it into .a and then have somehow it being part of the compiler, but that feels even more cheating. Like, sure, compiling it to assembly and then pasting it into the code might not be that bad, because it's like, I think it's a pretty good allocator. It does the job. But yeah. But yeah, like, ugh. So I don't know. So allocator, you specify the size. Then for free, it's funny. You have to. Oh no, it's fine. Yeah. So maybe I have to think about how we are gonna handle the memory, because on one hand, I kind of want to be lazy and use libc. On the other hand, maybe it's gonna be more fun to have our own allocator. So, the language is gonna be independent on libc. Or we can just do like an extremely simple allocator that never frees memory, and it just keeps allocating. Yeah, that could also work. You can think of it as we allocate a really big, like 64K for the stack, for our stack, right? Then we allocate at the end of that data structures that we add in our code and all of that crap, right? We place integers and then use them as pointers. So that's also an option. We might do that for the beginning, just to get some stuff going, right, to make it work. But I would really like to have custom allocator that's gonna be useful. Yeah. But anyways, like for the next time, let's add maybe a function parser, and yeah, probably better messages, a way to display the AST at the end. So yeah, I mean the AST, right? It's not gonna be more complicated than this. Maybe after adding the if statement. Yeah, but we'll see about that. So yeah, I think it's a pretty good progress for now. Like at this point, we are able to parse pretty much all the tokens that we have in plan to use. Maybe, you know, in the future, if statements, while loops, and so on. And we are also able to tokenize data structures. So, you know, obviously next step is to be able to parse a function and try to get some assembly going again. So yeah, thank you for watching, and I see you in the next one.